Hello, and welcome back to another fun mathematics lesson. We're going to be going into the next part of our rational number operations unit. So we first have done adding and subtracting positive and negative numbers. We went over the rules for those. Continue to practice that and really try to reinforce it on your own. We're now moving to the next phase, which is multiplying and dividing negatives. So today we will be multiplying rational numbers. So let's get right to it. The beauty of today and the next couple lessons is that multiplying and dividing negative numbers, the rules for doing both multiplying and dividing are exactly the same. So whatever we say for multiplication holds true for division and vice versa. There's no difference between the two. So let's get to it. The first scenario that we're going to look at is when you multiply or divide two numbers that have the same sign. And when I say have the same sign, I mean like both of them are positives, so two positives, or if they're both negatives. So both of the numbers involved in this scenario are either both positives or both negatives. When you multiply or divide numbers that have the exact same sign, then the rule is your answer, your product or quotient, is going to be positive no matter what. So an example in numbers, well, we know this is super simple. 18 divided by 3 is 6. But the same quotient would result if I did negative 18 divided by negative 3. Nothing is going to change numerically. The numbers all hold true. Right now, and anytime you multiply or divide, the only thing you're looking at is the type of number you are multiplying or dividing. Is it positive or negative? That is going to dictate whether you have a positive or a negative outcome. So since both numbers are negative, two negatives, that tells me my answer is going to be positive. And it's still 6. Nothing changes with the numbers. There's no funky, like having to do anything weird with the numbers. It's just looking at the signs. So rule number 1, if both numbers are positive or if both numbers are negative, your answer is going to be positive. One more example. Why not do something with fractions? So I'm going to come up with one. Let's do negative 1/3, and we'll multiply that by negative 2 3/4. Remember, this is a way you can write multiplication, by the way. When you have one number right next to another number in parentheses and there's no operation symbol in between them, it's inferred by people in mathematics that we are multiplying. So this is a multiplication problem. And when you multiply fractions, the first thing is you have to make sure that you have no mixed numbers. So we're going to make this an improper fraction first. So this is going to become negative 1/3 times 11/4, and it's negative. All right. Now, both of my numbers being multiplied are negative numbers. And since they're both negative, they both have the same sign, I already know my answer is going to be positive. I don't even have to worry about the fact that they're negative. It's just multiply as I normally would. So 1 times 11 is 11, and 3 times 4 is 12. So my final answer here is positive 11/12. Nothing changed because they were negative. I multiplied as I normally would, and then when I finished, I went back and said, all right, they're both negative, therefore my answer is positive. So that's rule number 1. Rule number 2 is when you multiply or divide numbers that have different signs. And when I say different signs, I mean like if you have 1 negative and 1 positive. So the signs are different. If the signs are different and you're multiplying or dividing, your answer is going to be negative. So the first example we'll look at is 3 times negative 4. I'm already going to know my answer is negative because I have one positive number and one negative number. And then I just do the math. 3 times 4 is 12. But my final answer is going to be negative 12. Why? Because I have two numbers being multiplied and they have different signs. One is positive and one is negative. The rule is if the signs are different, you have to make sure that your answer is negative. And we'll do one more example. And again, let's get some fractions involved. So let's use 6/5 and let's do a division problem. Divided by negative 4. Wow, that's a really bad 4. Negative 4/3. Instantaneously, I know that my answer is going to be negative. I have one positive number being divided by one negative number. Since the signs are different, the answer is automatically going to be negative. When you divide fractions, just as a quick refresher, you don't divide, you multiply by the reciprocal. Some of you, I know, use that little slogan, keep, change, flip. You keep the first fraction as is, you change your division, to multiplication, and then you flip, you find the reciprocal of the second fraction. So let's do that. This division problem is actually 6/5 times, and then negative 3/4. Now I can solve this. Again, I already know my answer is going to be negative. 6 times 3 is 18, and 5 times 4 is 20. So let's simplify this. My final answer is going to be negative 9/10. Boom. When the signs are different, your answer is negative. And those are the rules. That's pretty much today's lesson. I don't really use this when I teach, but for some people it helps. I've often seen the rules for multiplying and dividing negatives displayed in a tic-tac-toe board, which sounds a little weird, but it might help you to have a quick tool to help you remember the rules for multiplying and dividing negatives. So here's how it works. When you multiply or divide a positive and a negative together, your answer is negative. When you multiply or divide a negative by a positive, it doesn't matter, your answer is still negative because the signs are different. So the order of the numbers doesn't matter. However, if you multiply a negative by a negative, when the signs are the same, your answer is positive. And you'll see this little 3 in a row for the positives. So if you need a little visual reminder, maybe this will help you. If you set up a tic-tac-toe board and put pluses diagonally from top left to bottom right and fill everywhere else in with a negative, you have your rules set out for you. Positive times negative is negative. Negative times positive is negative. Negative times negative is positive. Not necessarily the most clever thing, but hey, maybe it'll help some of you, so figured I'd share. The thing I'm going to end with today is one extra example, and that extra example revolves around the idea of what happens when you're multiplying or dividing more than one number. And there's a couple different approaches you can take, but no matter what you do, you should all get the same answer. So one of the things you could do is just straight up do the problem in order, step by step. So step 1 is you could do negative 2 times 17, which is negative 34. Right? 2 times 17 is 34, and it's negative because one of the numbers is negative and the other is positive. And then that would leave you with negative 34 times negative 5. Well, a negative times a negative is a positive. So I know my answer is going to be positive, and in this case, 34 times 5 is 170, and it's positive 170. Other people will take that same problem, negative 2 times 17 times negative 5, and they'll say, we learned these rules, commutative property, associative property, etc. Well, in this case, You could use commutative property to switch the problem around a little bit. You could do -2 times -5 times 17. Might make it a little bit easier to work with. You would do -2 times -5. A negative times a negative is +10. And then your last step is you're dealing with two positive numbers. And 10 times 17 is very quick mental math. And that's 170. But either way, we got to the final answer of 170 for both scenarios. How you solve it is up to you. Just make sure that you are taking the time to maybe do it step by step and writing things out so you can visualize what you're actually doing and make sense of your work. As always, if you have questions, let us know. Reach out, join Google Meets, etc., etc. Keep doing great mathematical things and have a fantastic time doing it. Bye.